necessary condition for maximum and minimum when the function is differentiable. We earlier talked about the function is continuous, then the sufficient condition for maximum and minimum. Now we consider necessary condition for maximum minimum when f is differentiable. Okay, now let's the theorem is, if the function is differentiable function and x naught be a interior point of the domain, right, it is the interior point, then when we say that it is the maximum point or minimum point, if it is, its first derivative vanishes at x naught, right, that is f dash x naught is equals to 0. This is the necessary condition but not a sufficient condition, right? Now let us take the interior point x naught is in domain S, right, it is ds, it is in domain, so it's said to be stationary point if f dash x naught is equals to 0. Now when it is minimum point, x naught is a minimum point if f double dash x naught is greater than to 0. At x naught double derivative is greater than to 0, then it is x naught is said to be a minimum point, okay, of function. If a double derivative of function at x naught is less than to 0, then x naught is a maximum point, right? Now let us consider this and follow the example. Example is the function from r to r given by x cube, right? Though firstly we take f dash x is equals to 3x square, then when x equals to 0, then it is either given to be stationary point, maxima, minima, right? Now x equals to 0 is neither a minimum point neither a maximum point, it is a stationary point, not a maximum, not a minimum, because of double derivative does not exist, right? Now double derivative exists but it is also at the point at 0, so that is not for maximum, it is greater than to 0 double derivative, and minimum it is less than to 0, right? So it is not be sufficient condition, right? Now if the function is fx equals to x square, then f dash x naught is equals to 2x naught, which is equals to 0 when x naught is equals to 0. Now obviously x naught is a stationary point. This stationary point is minimum point, because if we take double derivative of this at x naught, this gives that 2 which is greater than to 0, because if we take double derivative then it gives 2 and putting the value of x naught, what is x naught? 0, and there is no x, so this is always greater than to 0, so this the function is given at 0, minimum point.